Hi everybody, going back to the DRO and the Harrison, one of the things I was able to do was make this. This is 3D printed. Oh, you're using plastic on a metal lathe? Indeed I am. This is going to be sitting behind the, actually it's going to sit, the orientation is going to be like this. It's going to be sitting like this, and then the reed head is going to be on this side. So these two narrow holes are going to be where the screws go into the back of the reed head, and these other two large ones are going to be going in the opposite direction. And you say, oh, where's the hole? Oh, I'll show you. The hole is right there, but the slicer in 3D decided that it needed some support, so it put it in there. So it's going to sit like this. It's 4.5 millimeters. It's within probably 10 thousandths of a slide between the cross slide and the reed head. So in other words, the cross slide is going to be on the left hand side. It's going to be moving back and forth, but there is a little bit of a gap there. That's kind of where I wanted it to be. So from that standpoint, just knock this out. I can control with 3D printing the dimensions very carefully. I can remake it in metal, but the point is, why? This thing is extremely strong, and here's the thing. It's only holding the reed head from the sliding load of that scale. There's not much going on there, so this will be like absolutely tremendously strong. And the good part is, because I can draw in Fusion 360 the dimensions, I didn't have to poke around to make it fit, because it actually does fit. And I'll bring you back and show you. Okay, there's that. These aren't the exact screws, these are just what I had on the desk, but they lined up perfectly. You might have to, in your 3D printing, do a secondary operation. Basically, chase it with a drill bit or something like that, just to take the fuzz off of it, or scratch it, as I mentioned in a previous video, with your deburring tool. That works really well. But you can see right here we have that. On the back side, you can see that I've already started breaking out that plastic. That's just a layer that was put in there to keep things where they needed to be. So right there, you pull that out, and then you're going to find is a nice countersunk screw hole for a M5 cap screw, and it works out well. So the issue I mentioned before is this is going to tie to the carriage, and then this is going to basically be tied to the carriage, and the scale is going to be moving back and forth. Now, one of the things you run into is it screws in too far. There is a certain depth, so be warned. There is very tight tolerance on the depth of the screws. So I went in a little too far. So what it's doing is it's actually tight against the back of the scale. So now this is going to be going back and forth. There you go, nice and easy. So the reed head's going to be fastened to the carriage, and then the scale is going to be moving back and forth with the actual cross slide. So the load on this thing, well, it's plastic. It doesn't really matter, because guess what? The force on this one is going to be going side to side. Good luck with breaking that plate along that real thin axis. It's going to be very difficult to hurt it. So I feel confident it's going to be fine. There's no heat there, there's no anything. And we're able to make it, as I mentioned, it's 4.5 millimeters. I can make it out of a plate, but the nice part about this one is I was able to take the measurements and actually put those into the design and print it right out and go to work straight away. No layout lines, nothing like that to have to set up. So anyway, just a quick update on that particular piece of the job. Just to take a quick second and highlight that I mentioned about the countersink for these 5 millimeter screws. Yeah, they're right there, and this is what popped out. So sometimes they're a little bit, you got to pry them out and so forth like that, but this one just printed into there, into the position, does the support function that the slicer decided that it needed, and then they pop right out, and which leaves you a fairly clean board. Again, you might need to scratch it a couple of times to get all of that out, but it certainly is nice just to drop a screw right into a countersunk hole you've already printed in. So, all right, thanks. Well, good evening. This is part 2 of the Harrison Lathe DRO install. We're still working on the cross slide, and in that cross slide I finally got the mounting done. As of I can check here, I think everything is still fine. Yep, still got clearance right here. And again, this is the first iteration. We will probably change it over time, but as of right now, it's on, it's straight, it's level. It's mounted in I think a pretty good spot. I mean, I don't think I'm going to have a lot of work pieces going on, and I'm going to shield it because I've got some access bolts right there. I can go ahead and do it. You'll see probably right here just a smidge of shim stock. I put it out 3/1000ths of an inch. Why? Well, in this design, it's fixed. The cross slide is going to slide, so I gave it just ever so small amount of gap. It's shimmed it equally at all those different points to just give it 3/1000ths worth of air gap. Why 3/1000ths? Well, I had a pile of shim stock here. You can see that. I snuck in the house. The wife's at the gym and I used her hole punch. Yay! I didn't need all that, so I do have it. It'll go in the top drawer of the toolbox. So anyway, it's on, it's straight, it's parallel, it's all those wonderful things. Not that it doesn't take a little fidgeting and fussing with to get it there, but your mileage will vary. I've got, what, 8 inches of cross slide space there. So any air, I got it down right at 1/1000th and a half over that entire span. I think with my scale of work, it's not going to be a big deal. So from that one, just going to zero that out. It's just wired right in. We'll get to the Touch DRO stuff here just shortly. But there's the display. Very nice. No backlighting that I'm familiar with here. As we said before, the batteries were supplied. Now, it is interesting because I'm just doing a quick check, just because it's what I do. And if we come down here, there, zoom in, you see that? Okay, back this up, can go back to 0 again. Now what's nice about these little Harrisons is they're dual scaled. So right now you're looking at the inch division. I can flip that around right into the metric division. It snaps right in there. So anyway, long story short, that's what you get. And again, it's in deeper than the other one. So there's actually 2 sets of numbers running around, but it's actually inset further. So the inch one is the furthest one out. Let's see if it will respond. I'm going to, let's see here. What's the best way to do this? How about that? Zoom out. Okay, first thing I'm going to do is I'm going to dial in 10/1000ths, just because. We dialed in 10. Again, a little bit extra there. It only shows 5. Well, yeah, on this one, this dial is set up for the diameter difference change, as opposed to it's 5/1000ths in, but it's 10/1000ths off the part. Okay. Same story true. There's 20, there's 10, there's 30. Right there, 40. And again, this is how accurate I was with the dial. 25/1000ths at 50. So that's my story, and I'm going to stick with it. But as far as responsibility, everything's going great. This is what you get in the box. No problem. Works great. Lots of people are using them. I'm going to go to the next level, which is specifically having a Touch DRO so I can have the tablet and get a lot more functionality out of it, as opposed to having just a standard. Now, if that's all you're going to do, that's great. I mean, that's rock solid. It works great. It's got a nice mounting hole on the bottom of it, little bracket as I showed you before, so you can actually mount it and swing it in, swing it out, whatever you like to do. We're going to go to the next level. Now, for those that are interested, we kind of talked about this before. distinctly about how I mounted it. So I'm actually right here, and I'll take that shim stock down. I mean, it's just there for proof. We've got it right there, and then we are tied off to the actual carriage. Let me go hands-free here for a second, and I'll show you. Get that out of your way. Turn on my light. There you go. So there's the two mounting screws. Yeah, I've got those shimmed too. Straight into the carriage. 5 millimeters worked out just fine. I like 1032s. I like 5 millimeters. They just seem to fit, and they feel, substantial enough where I'm not going to have any problems. So if you can see from that, and then there's the other side in the back, we've just mounted it very much like the front. We've got clearance in the front and the back. We're not going to scratch the way surface on the bottom that we talked about earlier. So from that, I think we're going to be good. It moves smoothly, no jumping around, no binding, and we'll go from there. I'll bring you right back with something I want to show you. Okay, this is that little 6-inch that I got extra that I thought was the right one, but anyway, it's here. Hopefully you can see the display there. What I want to show you was, if you look at this thing, I am whooping on that thing, bending it. That was my thumb, by the way. It is very resilient. If you can see that flexing I'm putting on it, it's very tolerant to that. That's pretty cool. So I'm going to let that go just to show me that if I do have such variation in there, this thing's probably going to tolerate it pretty well. That doesn't take care of my cosine error or anything like that, but at least gives you an idea that this thing is pretty robust. Okay, here's what I made. There's your version of it right here. Is the shim that I put on there. It's not touching the cross slide, but it's going straight down here, coming off the back of these. Never mind these screws, they were just on the desk. It's going straight in, they're countersunk, and then coming in from here, and on the flip side, these are countersunk. So these are where the 5 millimeters go in. The spacing is right. I think I fuzzed the bottom ones out like 1/2 millimeter each. They were at 5 millimeters and went to 5.5, just to give myself a little bit of flexibility there. And it worked out fine. But this is when I 3D printed, and it's 4.5 millimeters thick. It fits on there nicely. And I tell you what, with this thing going side to side, that is way tough enough to handle just about anything you want. I mean, this thing doesn't flex either. So it's plenty. I think it's fine. What's nice about it is I printed it. I was able to control the sizes very well on the 3D printer, and it was done. Okay, I'd still be probably scrounging for a piece of aluminum or something to do it and then play around with it. No, if you do it in Fusion 360, you set the whole locations. Now, with plastic, you do get a small amount of shrinkage when it comes in. I mean, we're talking a couple % or something like that, but very easily taken care of during the cleanup procedure. But it just makes things really nice to go ahead and print it, have it, prototype it like you saw me do with this in the back. I prototyped that, and it just worked out. So if you have 3D printer, you know, it's great. If you don't and you're interested, even a guy like me can run one, so not too bad. I have a Prusa Mini, which is very, very good. Expensive, but very good. And then I have an Ender 5 Plus. To give you an idea, the Prusa will do about a 7x7 block, 7 wide, 7 tall, 7 deep. And then the Ender will do 400 millimeters by 350 by 350. So yeah, it's big and it's noisy. So it stays in the back room. Meanwhile, the Prusa, I print most of my stuff with it because it just works. It doesn't require any fiddling or anything like that. Just turn it on and feed it filament and it goes. Okay, here it is in its glory, straight out of the bag, shipped from Yuri's Toys or TouchDRO.com. This is the TouchDRO. He's done his own private, let me turn this light back on. Circuit board, pre-printed, custom made for just this. It's very well designed. Everything's on it that you need. It's compact, it's tight, and it works right out of the box. It's pre-flash. You don't have to tinker with any of it. Just put it together, plug it in with a wall wart. It's a USB micro. Plug it in, and then you just plug in your scale. Yeah. So hopefully that's it. Then you set up the software, and then we have some calibration to do. We'll skip that until we have both axes on. I was just going to show you the cross-slide axis tonight, but that's it. So I'm going to slip this together real quick, put it in the box, and then I'll bring you back. But again, very nice setup, very affordable. I think with the box, it's like 99 bucks ready to go. He will actually give you the STL files. If you have your own 3D printer, you can print your own. I think I saw that on his website. So there it is. I'll bring you back when I get it slipped together. It's 4 screws and you put the board in. I think I can do that. Okay, there's the board out again. I think it's a 32-bit chip on this one. It's already got the Wi-Fi built into it. You can see the little antenna going on there. Again, very, very impressive. I like it. All right. Let's see, this should fit in. I think he said it was going to be snug. Okay, dropped right in the housing, no messing around at all. And then obviously the top goes on, but I believe this is an acrylic that we need to peel it and put it in. I'll bring it back. Okay, snaps right together, very nice fit. Doing a little 3D printing myself, it is very well refined. No crudity to it whatsoever. Plastic is good. All right, let's get the bolts in it. All right, it's a good sign. We've got communication going on. We've got lights going on. All right, let's finish up bolting it together. Okay, we've hooked up the scale. They're not marked on the outside, but if you look inward, you can see them. He's already got them labeled on the board for you. Let's see if we can make the connection. Okay, there's DRO, Touch DRO. This is the application. Okay, I think I figured it out. My HC06 is what I had on the other one. When I go to my available devices, there's Touch DRO. Okay. That was mostly operator error on my part. Finally got it, Touch DRO. Let's see if we can make it work inside the application. Connect, Touch DRO. Boom. Okay, after a couple of minutes of me not reading the instructions again, we're square. It's just typical Bluetooth hookup, getting it to pair nicely. So, long story short, it's the setup on the Y-axis, and that's completely up to you on how you want to do it. Zero it out, no problem. Let's do a quick stability test here. Let's go zero it out on the dial. All right, I'm going to go in 10 on the dial. It hasn't been calibrated yet, folks, so nobody get excited. Just saying, until you calibrate it, it's not going to be there. So that should be 5 thousandths. It's not there. It has a static number that it's using. So, okay. I think we're going to call it for this episode. That cross slide's on. We're connected to the Touch DRO. We need to go through the calibration, which I'm going to save until we do both all at once, but we're talking and we're walking and everything's going just fine. One quick test before I get off of here is disconnect, reconnect, Touch DRO. Happy now. I'm going to chalk it up to operator error, which is normal. Recovering from operator error is a specialty of mine. Awesome. Okay. Job is maybe half or 60% done. I don't know, but I'm going to load this one up so you guys have an idea what's cooking, and we'll go from there. Very doable. Very doable. So Mike, I think I'm going to earn that bean soup there. So if we can negotiate the extra meat substance that goes in it. Okay, call it. We'll be back for part 3. Okay, I couldn't resist. Same setup. I didn't move the tablet at all. I switched over, excuse me, in the settings, there is a preference bank. You can, there, that's way better, Dan. Okay, so I have bank A, bank B. A is my mill, and then B is the lathe, so I could actually have pretty much every machine in here talking to the same tablet if I want to. One at a time. But there you go. So I'm right there. Okay, I'm reaching across here. Here's my Y, X, Z. Same tablet, same everything. So again, these are like $100 for a 10-inch tablet. This is a Samsung. It's a good one, but it's been with me for 5 or 6 years now. So everything still works. So if I switch back to this, hitting the wrong thing, Dan. Settings, preference bank, B. Go back out here. Everything's plugged in. Okay, I got it. This is the Harrison lathe. Isn't that slick? I didn't move or unplug or do anything. Same tablet, same everything. The DROs are both paired, so as soon as I switched to preference bank, I'm off and running with the other machine. That's awesome. Okay, I wanted to add that tonight. Thanks, everybody.